Hello everyone and welcome to Fisimania. In today's video, we're going to do a little bit of math. So I was reviewing some of my notes on calculus. And so I was looking through some of these integrals and I thought, we should do a video about them. And so here I am. We're going to be doing some videos about some they're not hard, they're medium kind of like integrals, but I thought they would be good to kind of review. And so if you have never seen some of these tricks, then you can apply them yourselves. So let me make the intro not longer and let's go ahead and get started. So the first integral that we are actually going to look at is this integral where we have the integral limits from 0 to pi over 2, and then the integrand is 1 divided by 1 plus the square of the tangent of x, and obviously our variable is going to be the x variable. So to start off with this integral, we can try to simplify it by realizing that we have a geometrical trick or a geometrical identity that tells us that 1 plus the square of the tangent is equal to the square of the secant of this variable. And so if you remember correctly, then secant is 1 over the cosine of x, which means that then the secant square is going to be cosine, the square of the cosine, okay? This means then that our integral can be rewritten as 0 from pi over 2 of cosine squared times dx. Then we can use another identity, another geometrical trigonometric identity, which basically tells us that the square of the cosine, as we have here, the square of the cosine, can be written as 1/2 plus 1/2 of cosine times 2x. This is known as the double angle identity, which means then that our integral can be written as 0 to pi over 2 of 1/2 dx plus 0 to 1 to pi over 2 times cosine of 2x and a half here times dx. And so let us look now at, let us try to solve first the first term in this integral. And so we'll have 0 to pi over 2 of 1/2 dx. Obviously, 1/2 is just a constant, so we can just put it outside. And then the integral of dx is going to be x, which means now that we have 1/2 of x from 0 to pi over 2. And so obviously evaluating the 0 term is going to give us 0. So we only care about the term on top, which means that we're going to have 1/2 times pi over 2, which is pi over 4. The second term, the one that we have here, is going to be equals to 1/2 integral from 0 to pi over 2 of cosine of 2x times dx. Now, we should know that to solve an integral, we have to find a function that when we take its derivative, then we find the integral, the integrand that we have in our integral, right? Which means that we have to find a function that when we take its derivative, then we find cosine of 2x. We know that if that function is defined as sine of x, when we take the derivative of this function with respect to x is the same as taking the derivative with respect to that sine of x. And we know that the derivative of x, or of sine of x, is going to be equals to the cosine of x, right? Which means that our solution to our integral must be 1/2 times sine of 2x. Now we're missing one thing because here the argument is only x, right? However, if the argument of our function has something else, we need to account for the derivative of inside of that argument, which means that if or function of x is going to be equal sine of 2x, then we need to do the derivative with respect to 2x of sine times the derivative of 2x with respect to x. This means that we're going to have this being equal to cosine of 2x times the derivative of 2x with respect to x is obviously going to be 2. So we're going to have a factor of 2. Now, obviously, our integrand here doesn't have a factor of 2 outside. It has a factor of 1/2, which we're already accounting for it. Which means that if we want to find the true integral for this function that we have here, then we have to divide by a factor of 1/2 to get rid of this factor of 2 that we have here. And so this has to be evaluated from 0 to pi over 2. This means now that we'll have 1/4 times sine of pi over 2 times 2 minus sine of 0. Sine of 0 is going to be equals to 0. And then sine of pi over 2 times 2 is going to be sine of pi. And we know that the sine of pi is actually also 0, which means that this whole term is actually going to be equal to 0. Therefore, this implies that for our integral, the only value that we're going to get is actually going to be a contribution from the first integral, the first term in our integral, which means that we have pi over 4. So this is the first integral. Let's look now at the second integral, which we're going to be solving the integral of the natural logarithm with respect to x. Okay, this is ln, which is the natural logarithm. Now to solve this integral, we now have to use a very nice formula that we have basically to solve this kind of integral, which is called integration by parts. And so integration by parts tells us that the result for our integral is actually going to be given by the following formula, where we have u times b minus the integral from b times du. Okay, and what do I mean by this u, b, b du? So what I actually mean is that we are going to look at the structure of this integral, and then we're going to define some of these terms that we have here on the integral as u and some others as b, and then we're going to be able to find our result by using this formula. So let's look at this now explicitly. We're going to decide which one we want as u and which one we want as b. So let us start by choosing which one is going to be our u. In this case, we're going to choose u being equal to ln of x. And then v, we're going to choose by basically choosing first what we want as dv, as the differential of that b. And that in this case, the only thing left that we have here is the dx. So dv is going to be equals to dx. Now integrating both sides is going to give us that v has to be equals to x. And so before we go now with u, let us try to think, why do we want ln to be equal to u? The reason for this is because, as you can see here, in our solution, we have a differential that depends on u, which is basically du. So this means that we want to choose something or a function that its integral, that its derivative is actually going to be simple. And so it's going to give us a good form in order to solve that integral that we have left. And so actually this is very simple now, because du is actually going to be equals to the integral of ln, the derivative of the natural logarithm, which is 1 over x, times the differential of this variable x. And so now we have our form, the one that we want, which means that our integral is actually going to be given by u, which is ln of x, and then times b, which is x, minus b, which is x, times du, which is 1 over x times dx. So obviously the x's are going to cancel out, And then we can simply solve now our integral, which is ln of x times x minus x plus a, a constant of integration. And as you can see, this method gave us a very nice answer in very simple steps. So that is going to be all for today. As you see, a very short video, but hopefully you have learned some things. Please let me know in the comments if you would like to see more things like this. And thank you very much for watching my videos. See you next time.